Hey guys, Ms. Gosling here. In this video, you will be learning about Kirchhoff's laws. First, you are going to learn what Kirchhoff's laws are, and then after that, you will learn how to use them to solve circuit problems. So Kirchhoff's first law is the loop rule. The loop rule says that the total voltage change in a closed loop is zero. And what this means is that when I have a circuit, so for example, here's my voltage source, and I add a resistor in, the voltage that I put into the circuit by going across my voltage source has to be lost when I go across my resistor. So if I have a 5-volt battery, for example, that will add 5 volts to my circuit as I go across the battery. Then all 5 of those volts have to be dropped when I go across my resistor. This is a parallel circuit with 2 resistors. How much voltage will I lose across my second resistor? Well, let's look at our Kirchhoff loops. So, I can start at the positive terminal of my battery and go all the way around my loop through my first resistor, or I can start at the positive terminal of my battery and go around the second loop through my second resistor. So I have 2 closed loops in my circuit, and across each one, the total voltage change has to be 0. So, across my first resistor, I will still be losing 5 volts, and across my second resistor, I will also lose 5 volts. Now, let's talk about Kirchhoff's second law, which we call the junction rule. What the junction rule states is that the sum of currents flowing into a junction must equal the sum of currents flowing out of a junction. So let's go ahead and start with an example. I'm going to draw a circuit with one junction, and then we're going to talk about all the different currents in our circuit. So, let's talk about the currents in my circuit. Leaving my battery, I have a current, which I'm going to go ahead and call I1. And I1, when it reaches this junction here, is going to split off into currents I2 and I3 as it goes through my 2 separate resistors. But then, at this junction here, my currents I3 and I2 will return and reform back into I1. And so what I can say is that the relationship between my 3 currents is as follows. I1 is equal to I2 plus I3. And I can see that at my first junction, and I can see that at my second junction. So let's do an example. What I'm going to do is I'm going to find the current at all points in my circuit below. So what I'm going to start by doing is drawing my separate currents. So I've got I1 leaving my initial battery. I have I2 going through my first resistor, and I have I3 going through my second resistor. So let's talk about how we can find all of our currents, I1, I2, and I3. So let's talk about what I know. I know that my voltage is 50 volts. I know that R1, which I'm going to say is the top resistor, is 10 ohms. And I know that R2, my bottom resistor, is 20 ohms. Additionally, I know from Kirchhoff's first law, the loop law, that the voltage drop across both of my resistors has to be 50 volts. So I'm going to say that V1 is equal to 50 volts and V2 is equal to 50 volts. And those are going to be all of my givens. So let's go ahead and talk about my unknowns. As of now, I need to find I1, I2, and I3. So those are my unknowns. And to figure out the values of those resistors, I'm going to need 3 equations. I have 3 unknowns, so I need 3 equations. So let's start with my current 2 and my current 3. So current 2 is traveling through resistor 1. So what I can say is that the voltage drop across resistor 1 is equal to the resistance of resistor 1 times the current through resistor 1, which is I2. Or I2 is equal to V1 over R1. Then I can say V2 is equal to R2 times the current through resistor number 2, which is I3. And so I can say that I3 is equal to V2 over R2. And then finally, I know from Kirchhoff's junction rule that I1 is equal to I2 plus I3. So now I have everything I need to know to solve this problem. I know from Kirchhoff's loop rule that my voltage drop across my two resistors can be used to find my current through each of those resistors. And then I know through the junction rule that I can add those currents together to find the total current leaving my battery. So let's go ahead and substitute and solve. So let's start with I2. So again, I know that I2 is equal to V1, which is 50 volts, divided by R1, which is 10 ohms. So then I2 is equal to 5 amps. So there is I2. Let's do I3 now. So I3 is equal to V2, which again is 50 volts, divided by R2, which is going to be 20 ohms. And what I'll find is that I3 is equal to 2.5 amps. Finally, I need to find my final current, which is the current leaving my battery. And again, from Kirchhoff's junction rule, I know that I1 is equal to I2 plus I3. Or I1 is equal to 5 amps plus 2.5 amps, giving me finally that I1 is equal to 7.5 amps. And there you have it, folks. You now know what Kirchhoff's two laws are, and you know how to use them to solve a problem. So now it's your turn. Happy solving!